Hey everyone! In this video we are going to be looking at one-dimensional inelastic collisions. The difference between these and the elastic collisions is that once the two objects collide, they stay stuck together. Now let's go ahead and highlight the key information. Ryan, with a mass of 75 kilograms, is running east at 8 meters per second. And if we remember from previous practice, if it's east, that's going to the right, which means this is going to be a positive 8 meters per second when we fill it in. Hugh, who has a mass of 90 kilograms, is running west at 6 meters per second. And again, if we remember that east is going to be positive, it's important in a moment that that west 6 meters per second is going to be negative. They jump into the air just as they reach each other and hug as they collide. What velocity will they have? So we're going to start off by writing out our equation for inelastic collisions. m1v1 plus m2v2 is equal to, and the difference between this one and elastic is that the m1 plus m2 terms are combined and we only have one velocity prime. So remember this v prime means the velocity after the collision, and because they are stuck together, embraced in their hug, they basically count as one big Ryan Hugh-sized blob, and we're going to treat them like that. Our m1, which we can decide is Ryan, it doesn't really matter, you can do it backwards, you'll still get the same answer, but I typically use whatever object shows first as being number 1. Our mass of Ryan is 75 kilograms. And Ryan's initial velocity is 8 meters per second. M2 is the mass of our second object, in this case, Hugh, who has a mass of 90 kilograms. And Hugh's velocity, that's the V2, is west at 6 meters per second. And like we just said, don't forget, if you're going west, that's a negative value, -6. If you don't do that, you're going to get some wonky answers. Our combined Ryan-Hugh object is 75 plus 90, and we need to find v prime, which is the velocity that they go as they hug. Keep in mind that there is some perfect velocity that they could have ran at each other, that their hug would be completely canceled out and they would thump straight down on the floor. You also have to keep in mind that if a football player runs at a small child, jumps into the air and hugs, they're going to very much go in the direction of the football player. So we can fill in these numbers, knock this out. This is 600 subtract 540 is equal to 165 v prime. Like all momentum equations, the hard work is filling it in. Once it's filled in, we're going to get something nice. It's 60 equals 165 v prime. Divide both sides by 165, and we're going to get a v prime equals 0.36 meters per second. The fact that that is positive means that as Ryan and Hugh leap into the air and hug each other, Ryan's going to slow down, but keep going in the direction that he was going, and Hugh is actually going to get knocked backwards. So at the end of this hug, they've actually moved slightly back towards the way that Hugh was going. Let's go ahead and look at another example where we're solving for mass. So this is an inelastic collision problem where we're solving for mass. We know that it's inelastic because once the two objects collide, they stay stuck together. Let's go ahead and highlight important information. Our first object is a steel ball, and it is launched at 30 meters per second into a stationary block of wood. And I did that this time on purpose because sometimes my students miss that when it says stationary, that's actually telling us a velocity. We'll get to that in a moment. It does tell us that the mass of the block of wood is 10 kilograms. The steel ball embeds into the block and causes it to slide across a table at 0.5 meters per second. This word embed is actually helpful because it does tell us that it's an inelastic collision. If they had said the steel ball bounces or the steel ball ricochets, anything like that, we would have known this is an elastic collision, but it's an inelastic collision because it embeds it, it's stuck. We've been asked to solve the mass of the steel ball. Let's go ahead and get our equation up for inelastic collision. It's m1v1 plus m2v2 equals, remember the difference between this and elastic is that our two objects combine to become one super object, and we only have one velocity after the fact. This v prime means their combined velocity after the collision. m1 is the mass of the steel ball, which we've been asked to find, so we don't know the mass of the steel ball. It stays m1. We do know the velocity of the steel ball. It's 30. Plus m2, the mass of our block of wood. That's 10. We need to find the velocity initial of our block of wood. The key word here is stationary. Stationary means that it was not moving. So if you ever see that word, stationary or at rest, you do need to know that initial velocity was 0. It makes the calculations easy, but you have to be the clever little cupcake to figure out that it was 0 to begin with. Now our combined mass is going to be the m1, which we don't know this time, plus 10 multiplied by this v prime. Now it causes the block to slide across the table at 0.5 meters per second. If you're trying to decide if that's positive or negative, you need to keep in mind that if the ball was going 30 meters per second, in whatever direction that you choose, and it hits a stationary block, that velocity is going to be in whatever direction the ball was launched. So because we started with a positive 30, this velocity also has to be positive. That would be absolutely wild if we launched a steel ball into a block of wood, and then the block of wood flew back towards us instead of being knocked away. So they're going to go in the same direction. At this point, we can start tidying this up with a little bit of math. And we end up with 30 m1. This term vanishes. 10 times 0 is gone. We're going to multiply this 0.5 in using our little distributive property here, and we end up with 0.5 m1 plus 5. This is going to tidy up so quickly once we've filled these things in. We subtract 0.5 m1 from both sides, and it's going to leave us with 29.5 m1 equals 5. In order to get rid of this 29.5, we divide both sides, and we're going to get that the mass of our steel ball, m1, is equal to 0.17 kilograms, which makes sense for a little steel ball that we've launched. I hope that this was helpful. This was 2 different examples of inelastic collisions, one where we solve for velocity and one where we solve for mass. If you have any other questions, please feel free to leave them down in the comments below. I hope this helps.